Hey everyone, I welcome you back to this channel after a long time. As you have wished, today we will solve PYQs from rotation chapter. So we will include speed solving as well as formulas and important concepts will be discussed in this video. So let's get started. So here is our first question. It says two identical spheres each of mass 2 kg and radius 50 cm are fixed at the ends of a light rod so that the separation between the centers is 150 cm. Then moment of inertia of the system about an axis perpendicular to the rod and passing through its middle point is x by 20 kg square. I have to find the value of x. So without diagram nothing will happen. So let us draw the diagrams. So this is our sphere and here is another identical sphere. And radius is given as 50 cm, so 1 by 2 meter. Mass is 2 kg. Since these are identical spheres, I am writing for only one sphere, and this is also same. And I have to find the moment of inertia through this axis passing through the midpoint. So I have to find moment of inertia over here. And this distance, this is given as 150 centimeter. So this is 1.5 meter. So this distance, small distance, let it be r. This no, r is radius, so let it be d. So d is 1.5 by 2. Now I have to find moment of inertia. I net. This is equals to moment of inertia for a sphere. Here the sphere is solid sphere. It is 2 by 5 mr square, and this distance, this is plus md square. So this will be the moment of inertia for one sphere through this perpendicular from the center, and I have been told that there are two spheres, so I will do 2 times this. So I will get the net moment of inertia. So calculating 2 by 5, m mass is given in the question, mass 2 kg, r is 1 by 2, so 1 by 4 r square, plus m d. D is what? 1.5 by 2. 1.5 is 3 by 2, so I will get 3 by 4. So 9 by 16. So this is 2 times. This gets cancelled. 1 by 5 plus 9 by 8. So calculating it, 2 into 8 5 40 LCM, and above it is 8 plus 45, so 53. So ultimately I will get 53 by 20 kg meter square. In the question it is told that it is x by 20 kg meter square. So from here I can say that x equals to 53. So I found out x is 53. So this is the correct answer to our question. So the next question says a solid circular disc of mass 50 kg rolls along a horizontal floor so that its center of mass has a speed of 0.4 meter per second. The absolute value of work done on the disc to stop it. So absolute value of work done. So this is equals to nothing but the change in kinetic energy. So delta K. And here the kinetic energy will be for both, for translation and as well as for rotation. So kinetic energy total, this is equals to half mv square. This is kinetic energy translational plus half I omega square. This is kinetic energy rotational, KET plus KER. And generally in my JEE time I used to write it half mv square K plus 1. This is total kinetic energy, and where K is generally the coefficient, like I equals to mr square, and in this question it is solid circular disc, so half mr square. This coefficient half, this only I used to denote by K, and K is not the radius of gyration. In many books it is written by K. Here this coefficient is K, so this is the direct formula for total kinetic energy. So I will get half, mass is 50 kg, 50 into V square. 0.4 square is 16 by 100 and k plus 1, half plus 1 is 3 by 2. So I will get again 2, so 4. So I will get 6 joules. So the absolute value of work done on the disk to stop it is 6 joules. So this is the correct answer to our question. So next question says, two disks of moment of inertia I1 4 kg meter square and I2 is 2 kg meter square about their central axis and normal to their planes, rotating with angular speeds. So omega 1 will be 10 radians per second and omega 2 will be 4 radians per second respectively, are brought into contact face to face with their axis of rotation coincident. The loss in kinetic energy. So I have to find the loss in kinetic energy of the system in the process. So basically this is a disk number 1. I is given as I1 4 kg meter square and it is rotating with omega. So omega 1 is 10 radians per second. And this will be a second disk, disk 2. Here I2 is given as 2 kg meter square and it is rotating with omega 2, which is 4 radians per second. And it is told that both these disks are brought into contact face to face. So I will get a figure like this where both the disks are in contact. Here I, moment of inertia, will be I1 plus I2. So I1 is 4 and I2 is 2. So this is 6 kg meter square and it will rotate with another omega. Let it be omega dash. So I need to find omega dash. So first of all I will use angular momentum conservation. So I1 omega 1 plus I2 omega 2, this is equals to I3 omega 3. I have told it omega dash. So I1 is 4 omega 1 10 plus I2 is 2 omega 2 4. This is equals to 6 into omega dash. So I will get 40 plus 8, 48. This is equals to 6 omega dash. So I will get omega dash equals to 8 radians per second. Now we need to find what is the energy lost. So U loss, this is equals to delta K, change in kinetic energy. And in this question entire the kinetic energy is rotational kinetic energy, and rotational kinetic energy KER, this is equals to half I omega square. We know this. So I will use initial kinetic energy is half I1 omega 1 square plus half I2 omega 2 square minus half I3, this one is I3, and omega dash square. This is our final kinetic energy. So placing the values, I will get half I1 is, in the question it is given 4 radians, 100 which is 10, omega 1 was 10, so 10 radians is 100 plus half I2 is 2 and omega 2 was 4, so into 16 minus half I3 is 6 into 8 square 64. So ultimately I will get 200 plus 16 minus 192. So this turns out to be 24 joules. So the correct answer to our question, the loss in kinetic energy of the system in the process is 24 joules. So this is the correct answer to our question. A body of mass m is projected with a speed u making an angle of 45 degree with the ground. The angular momentum of the body about the point of projection and the highest point is expressed as, in this way I have to tell what is the value of x. So we need to find angular momentum. So in this question it is talking about a projectile motion. So let me draw. This is our coordinate system, this is our origin, and the projectile is somewhat like this. And the mass here m, this is projected with a speed u, and in the topmost point this will be our velocity. If this is angle theta, theta equals to 45 degree given in the question, so this will be u cos theta. and this will be our maximum height h max. And in the question I have to find angular momentum. So angular momentum L, this is equals to mvr, and I have to find the angular momentum from the origin. The angular momentum about the point of projection, because I have taken the origin as a point of projection. So this h max, this height is r. So I have known that h max, this is equals to u square sine square theta upon 2g. This is the basic formula for projectile motions, so I will use this formula. So angular momentum m, v, and r I will use, no, v is u cos theta, sorry. So u cos theta over here, and r is u square sine square theta upon 2g. So I will get mu cube by 2g, and cos 45, because theta is 45, cos 45 is 1 by root 2, and sine 45 is also 1 by root 2, but I have been given sine square, so 1 by 2. So I will get mu cube by 4 root 2g. Now in the question, this is the pattern I have to follow. Root 2 will be in the numerator, so I will rationalize it. I will get root 2 mu cube by 8g. So this is matching with this. So from this I can say that x, this is 8. So the value of x is 8. So this is the correct answer to our question. So we have our next question. A ring and a solid sphere roll down the same inclined plane without slipping. They start from rest. The radii of both bodies are identical and the ratio of their kinetic energies is 7 by x. We need to find the value of x. Now they have tried to trick you in this question. Basically, suppose this is our inclined plane. Inclination angle is theta. This is our ground level, and this is height h. Now if this ring is placed over here, let this be ring. At the same time, let this also be representing the figure for solid sphere. So you can say that this ring will come down, or the solid sphere will come down and will come over here. So in either of the cases, the potential energy P, this will be equals to kinetic energy K. Now the potential energy P for ring, this is equals to mgh, no problem. And also potential energy for solid sphere, this is also mgh. So both the potential energies are same because they are kept at the same position, and when they will fall down, both the kinetic energies will be same. Why? This is because I have used energy conservation. So I can say that ratio of kinetic energies, this is equals to 1:1. So 7 by x, this should be 7. So the correct answer to our question is 7. Now let us see what this question says. Consider a disk of mass 5 kg, radius 2 meter, rotating with angular velocity of 10 radians per second about an axis perpendicular to the plane of rotation. An identical disk is kept gently over the rotating disk along the same axis. The energy dissipated so that both the disks continue to rotate together without slipping is. So basically we are given the diagram. First of all, this is the disk 1, and let I be the moment of inertia for this disk. And if I try to calculate the moment of inertia I for a disk, it is mr square by 2. So m, mass, is given as 5 kg, radius is 2 meters, so 2 square 4 by 2. So this is 10. So I found out the moment of inertia. Now if another disk, similar disk, is placed over it, here it is given in the question, an identical disk is kept gently over the rotating disk. So the entire moment of inertia for the total system, that will be 2i. So let me draw it. This was case 1, and it was rotating with omega, and this was I. Now in case 2, this is one disk, case 2, and we have been told that another identical disk is placed over it. These are identical disks. So here the moment of inertia will be 2i, and here omega will be, let it be omega dash. So I know that I can conserve angular momentum. So conservation of angular momentum, and it is I omega equals to constant. So for case 1, I omega, this is equals to, for case 2, 2I omega dash. So I will get omega dash, this is equals to omega by 2, and in the question it was given that omega is 10 radians per second. So 10 by 2, this is 5 radians per second. This is omega dash, the second case. Now in the question we have been told the energy dissipated so that both the disks continue to rotate. So energy loss I have to find out. U loss, this is nothing but delta Ke, the change in kinetic energy. So half I omega square. I am using kinetic energy rotational because for this disk there is no translational kinetic energy. So half I omega square, the initial kinetic energy, minus half I, which is 2I omega dash square. So half I is 10, I found out I, and omega square, omega was 10 in the first case, so 100 minus half into 2 into 10, 2I, into omega dash is 5, so 5 square 25. So ultimately here I will get 500 joules, and in the second case it is 250. So ultimately 250 joules, this is the energy loss. So the final answer to our question will be 250 joules. The next question says a heavy iron bar of weight 12 kg is having its one end on the ground and the other on the shoulder of a man. The rod makes an angle of 60 degrees with the horizontal. The weight experienced by the man is. So let us draw the figure first. Let this be our man, this is our ground, and rod is inclined in this way. This is our rod, and in the question this horizontal angle is 60 degree. Now let us try to draw the FBDs. So here will be a normal N1, and it is resting on the shoulder of the man, so the normal in this direction N2. Mg is acting downwards, Mg, and frictional force is acting backwards, F friction. Let this be point A and this be point B. So I have drawn all the forces of the FBD, and now what I will do is I will do tau net, torque net, this is equals to 0, and about point B I am doing this. So about point B, N1 and F, these two forces will have 0 torque because these are passing through point B only. So only I have to do N2, and because of Mg. So from here I will get N2 into, that for torque, force into distance, distance is length of the rod L, this is equals to Mg, and the length will be this projection of Mg, and this will be the length. So here Mg into L by 2 cos 60, this length, this is L by 2 cos 60. So I will get L gets cancelled, N2 equals to Mg by 2, and cos 60 is another 2, so Mg by 4. So from here I will get weight experienced by the man. So this N2, this will provide us the necessary force, or the man will experience the force because of this N2. So I will get normal reaction N2, this is equals to, mass is given in the question as 12 kg. So 12 into G by 4, this is 3G. So ultimately the force experienced, this is equals to 3 kg. So the correct answer to our question is option number 3, 3 kg. So next question is a simple one. 4 particles each of mass 1 kg are placed at 4 corners of a square of side 2 meter. Moment of inertia of system about an axis perpendicular to its plane and passing through one of its vertex. So passing through this vertex I have to find the moment of inertia. So here is a mass of 1 kg, mass of 1 kg and mass of 1 kg. Here also mass is there, but since the axis is passing through this, so moment of inertia for this mass will be 0. Now this side is given as 2 meter. Let me write it as A. And this diagonal will be root 2a. So if I try to find out the moment of inertia I, this is equals to, for this mass, ma square plus for this mass m root 2a whole square plus the third mass ma square. So this is ma square plus 2ma square plus ma square. So ultimately moment of inertia about this axis will be 4ma square, and putting the values, 4 mass is given as 1 kg and a is the side is 2 meters, so 2 square, so this is 16. So the correct answer to our question is 16 kg meter square. So here is our next question. A particle of mass m projected with a velocity u making an angle of 30 degree with the horizontal. The magnitude of angular momentum of the projectile about the point of projection when the particle is at its maximum height. So it is talking about a projectile motion. So let us draw it. This is our coordinate system and projectile has been started from the origin. So this is our projectile. Now suppose the mass is projected with a velocity u. At the topmost point, this will be equals to u cos theta. The theta is this angle and it is also given 30 degree in the question, and this is our height h max. So angular momentum L, this is equals to mvr. Now from origin, what is r? R equals to h max. V we know, V equals to u cos theta, theta is 30 degree, and m is given in the question. So L, angular momentum, this is equals to m, V is u cos 30, and h max, what is the formula for h max? You have learnt it in projectile motion. H max, this is equals to u square sin square theta upon 2g. So I will make use of this, u square sin square 30 by 2g. So I will get L, this is equals to mu cube by 2g, and cos 30, it is root 3 by 2, and sin 30 is half square is 1 by 4. So ultimately I will get root 3 mu cube by 16g. So this will be our required angular momentum. So I can see that option number A, root 3 mu cube by 16g. So option 1 is the right answer to our question. So here is our next question. It says a uniform rod AB of mass 2 kg and length 30 cm at rest on a smooth horizontal surface. An impulse of force 0.2 Newton second is applied to end B. The time taken by the rod to turn through at right angles will be. So let us first draw the rod. Suppose this is a rod. This is end A and this is end B. Now impulse of force 0.2 Newton second is applied to end B. So this is our impulse. The time taken by the rod. Okay. Now after applying the impulse, this rod will definitely rotate with some omega in this fashion. And also we know that at the geometric center, the moment of inertia I, this is equals to ml square by 12. You should all remember the moment of inertia formulas. At the end it is ml square by 3 and at the center it is ml square by 12. I am not putting the values now, we will do at the end. You should also keep the formulas as it is and try to do the calculations at the end. Okay. Now we know that theta, this is equals to omega t. Now the time period, we have to find out the time taken by the rod. So time will be equals to theta by omega. So we only need to find what is omega and what is theta in order to find the time taken by the rod to turn through at right angles. Now to find omega, we know that angular momentum tau dt, this is equals to I omega. Now tau dt is fr dt. This is equals to I omega. So if I take out r from here, and integration will be f dt, this is equals to j, impulse. So r into j, this is equals to I omega. And from here I can say that omega equals to rj by I. So we have found out the angular velocity omega. Now let us put the values and find out what is omega. So putting the values, omega equals to r in the question given as length 30 centimeter, but we have to do L by 2, this length. So 0.3 by 2. In the question j is given 0.2, impulse I also written it down. So 0.2 by I in the question was not given. I found out ml square by 12. M is 2 kgs. Yes, 2 kg. L square 0.3 into 0.3 by 12. So 0.3 gets cancelled. Points get cancelled. So 3, 4 and 2 and 4 gets cancelled. So I am left with 2. So omega is equals to 2 radians per second. Now theta, this is given in the question, pi by 2 given. The time taken by the rod to turn through right angle, so pi by 2. So I will ultimately get time t equals to theta by omega pi by 2 into 2 for omega, this is pi by 4. So I have to find the answer in pi by x format, where x will be 4. So the correct answer to our question is 4. So here is our next question. A body of mass 5 kg moving with a uniform speed 3 root 2 meter per second in xy plane along the line y equals to x plus 4. The angular momentum of the particle about the origin will be. So let us draw the diagram. This is our coordinate system. And the line is y equals to x plus 4. The line will be in this way. Positive slope. This is line y equals to x plus 4. And this is our origin. Now I know that angular momentum L, this is equals to mvl, or let me write mvr. What is r? R is this perpendicular distance. This is r. So main question is to find the r. And in the question we are also given that mass is 5 kg and velocity v, this is 3 root 2 meter per second. So mainly we have to find r. So you know, you have studied in mathematics how to write r. By the way, talking about mathematics, please tell me if you are interested in the JEE Advanced series. I will also continue that one too. Please mention that in the comment section. And okay, moving back to this question. So r will be, okay, the equation was y equals to x plus 4. So from here I can say r equals to modulus of 4 in the numerator and denominator, coefficient of x square plus coefficient of y square. So this is 4 by root 2. So 2 root 2 is distance r. So L mvr, this is equals to, m is mass 5 kg, v is 3 root 2 and r I have found out 2 root 2. So 5 3 15, 20 and 13 to 2 60. So 60 kg meter square per second. So 60 is our final answer. So here is our next question. A cylinder is rolling down on an inclined plane of inclination 60 degree. Its acceleration during rolling will be x by root 3 meter per second square, where x is. So first of all, let me tell you what is the formula to be used for acceleration. Suppose this is an inclined plane. The body is rolling over here, and if I try to draw the FBDs, and first of all let me draw, this is theta, angle of inclination. So this will be mg sin theta. You know how to convert into components because this will be mg. And friction will act in this direction, friction. So I will get acceleration equals to net force mg sin theta minus friction F divided by m. This is our acceleration. We also know that I alpha, this is equals to torque, and torque is due to frictional force, so Fr. And since this ball is performing pure rolling, I will use the condition for pure rolling, A equals to R alpha. From these three equations, so number 1, number 2 and number 3, you will get that F, frictional force, this is equals to mg sin theta divided by 1 plus mr square by I. And further you will get that acceleration A, this is equals to g sin theta divided by 1 plus I by mr square. Now this is the formula, I think you know everyone. I just derived it for you. This is the formula you should know. Now in the question we are given it is a cylinder. For cylinder, I cylinder, this is equals to 1 by 2 mr square. So I will get I by mr square, this is equals to 1 by 2. Now I need to find what is the acceleration during rolling. So I will use this formula directly over here. A equals to g sin theta 1 plus I by mr square. So g, and the angle we are given 60 degree inclination, so sin 60 divided by 1 plus I by mr square, I have found out 1 by 2, so 1 by 2. So I will get g root 3 by 2 into 3 by 2. So ultimately I will get g by root 3. In the question I have been told that use g equals to 10 meter per second square. So this is nothing but 10 by root 3. So equating with this, I will get x equals to 10. So 10 will be our final answer. Now in my JEE time, I used to learn this formula, A equals to g sin theta 1 plus k. Now short trick, now k was not radius of gyration. Many books denote k as radius of gyration. This k was nothing but I by mr square. It was different for sphere, solid sphere, then hollow sphere, then cylinder, and you should remember all this for speed solving. So this is probably our last question. This question says a disk of radius r and mass m is rolling horizontally without slipping with speed v. It then moves up an inclined smooth surface as shown in figure, the maximum height that the disk can go up the incline. So you can see in the figure that this is the disk and it moves up. It is also given that it is a smooth surface. So this one is smooth. So here I can use energy conservation. Which is kinetic energy, and this disk will have kinetic energy translational KET plus kinetic energy rotational, and this entire energy will be converted into potential energy plus kinetic energy rotational. Now you might argue why this kinetic energy rotational is here. It is because it is given that this surface, this is smooth. So whatever omega this disk is revolving with, the same omega will be in this position. So kinetic energy rotational will remain constant. So I can cancel out kinetic energy rotational from both sides. So kinetic energy translational, this is potential energy, and kinetic energy translational is half mv square. This is nothing but potential energy mgh. From here I will get h equals to v square by 2g. So this will be our final answer. Now looking at the options, I can see option 3 is v square by 2g. So this is the correct answer to our question. Now please don't use here kinetic energy equals to half m v square k plus 1. Don't use this formula over here, because in the question it is given smooth surface and you need to take kinetic energy translational, kinetic energy rotational separately, because kinetic energy rotational remains unchanged.